This is Chris, and we are taking a look at questions 13 and 14 here in section 4 of SAT Practice Test 4. So for 13, it says the population of mosquitoes in a swamp is estimated over the course of 20 weeks as shown in the table. And we see the table below. And they say, which of the following best describes the relationship between the time and estimated population of mosquitoes during the 20 weeks? Well, first of all, we see, hopefully, without too much investigation, that if we look at these as our corresponding x and y values, we see that as one goes up, the other one also goes up. So they're both definitely increasing. So we can maybe eliminate b for decreasing linear and eliminate d for exponential decay. So decreasing and decay would both be going down. And so here, we know it's some version of increase, and we want to just figure out if this is going to be linear or exponential. So you can look at the difference in your x's and the difference in your y's, and you could check the slope between 2 points if you wanted to look at this like mathematically. So you could pick any 2 coordinates, check the slope there, and then pick any other 2 coordinates, check the slope there. You can also try to look at this visually. And here, if you were to do 0 and 100, so if we mark these off by hundreds, 1, 2, 3, 4, let me zoom in down here a little bit, 5, 6, 7, 8, 9, and 10. So that would be 1,000, and that would be 100. So here, if you do 0, 100, and then you do 1, or 2, 3, 4, 5, and 1,000, and then you do 1, 2, 3, 4, 5, and then you try to do 10,000. Well, you can already see that's going to be like maybe somewhere up here, but like almost off the page. So it's really hard because these numbers are so large to get a visual depiction of it to really tell if it's linear or a curve. To graph that very exactly would be also a little bit of a challenge. So that's maybe not our ideal method on this. So let's just look at our x values. We see that these are all spaced out by 5. It's going up by 5 every time. Up by 5, up by 5. So an increase of 5, increase of 5, increase of 5 all the way. So in order for it to be linear, that means the y values would have to increase by the same amount each time. So here that's going up by 900. And then here that's going up by 9,000. And so already, whenever we see a difference, as those y values increase by a greater amount each time, that lets us know that it's exponential. And we can see that from the pattern in these numbers, hopefully without having to either calculate it by using slope or without having to try to graph something that's going to have a y-axis with some pretty wild values that's going to make it a little bit tough for us to graph accurately. So whenever you're asked to differentiate linear versus exponential, just look to see if the y value is increasing at the same rate each time as the x value increases at that constant rate. Now up next, we'll take a look at question 14. And this one's going to look yucky at the beginning, but I promise you they give us all the information we need. It's not as bad as it seems at first glance. But I will admit that at first glance, this equation looks kind of intimidating. So let's see what they say in the word problem. See if they help offer a little bit of insight into what that equation actually means. So here it says the expression above gives the amount of money in dollars generated in a year by a $1,000 deposit in a bank account that pays an annual interest rate of R% compounded monthly. Which of the following expressions shows how much additional money is generated at an interest rate of 5% than at an interest rate of 3%? Okay, so these interest rates of 5 and 3, well, they tell us in the question that we're plugging those values in place of R. So let's just write out an expression for each. So the 5% rate would look exactly like that equation that we see above. It'd be 1,000 times 1 plus, and then in place of R, we're going to replace that with a 5. So it would be 5 over 1,200, and then the whole thing to the 12th. Now and that's for the 5% interest. And then they want us to compare that to what's generated at 3% interest. So let's take a look at that one. And again, we're going to just use this same equation from the top, and we already know because they told us in the question that we're going to plug in whatever the rate is in place of r. So this would be 1,000 times 1 plus 3 over 1,200 to the 12th. So let's start with just those two pieces, and then let's see what the question is asking. The question wants to know how much additional money, how much more did we gain in interest with the 5% rate than with the 3% rate. So basically, they're saying, hey, this is how much more than this. And in order to figure out how much more one value is compared to another, just like if I said, hey, if I'm comparing 7 to 2, how much more is that? Well, you might in your head just automatically go, oh, it's 5 more. But the way that you got that was by subtracting those. We're just subtracting the larger result, which would be here the 5% interest, minus the smaller result, the 3% interest. So let's see which one has these expressions written out where it's going to be this one minus this one here. And if we look, we see that that matches up with what we see in answer choice D. So although these expressions look very complicated, and they are, but luckily we don't have to solve them numerically. We really just have to answer the question of how much additional, and when they're looking for how much additional, that means you're taking a larger value.